for solving this particular problem is to understand what it's asking. It's asking you to find the radius, which is given by this formula. R equals the cube root of the gravitational constant times mass times time squared all over 4 pi squared. Now, as you can see, I've taken my g, my m, and my t, and I've already plugged them into the formula here. So instead of a g, I put a 6.67 times 10 to the negative 11th, and newtons is given by m times kg all over s squared, so I put that in there. And you also have to bring the m squared over kg down. The mass, m, is 5.98 times 10 to the 24th kilograms. And inside parentheses, so I square it, is the time, 2.6 times 10 to the 6th seconds. And when you multiply that out, it's 2.6 squared, which is 6.67 times 10 to the 12th. Now, the next step that I'm going to do is group the like things together. Now, it's all multiplication, and we know multiplication is commutative, so I can move stuff around. For example, I can take the 6.67, the 5.98, and the 2.6 and multiply all those together. I can also take the 10 to the negative 11th, the 10 to the negative 20, or 10 to the positive 24th, and in this case 10 to the positive 12th, and add those together. They have like bases, and you just add the exponents. And then finally you can put together your units. I got the units for g, the units for m, and the units for time. Now, the neat thing is when I multiply out 6.67 times 5.98 times 6.76, I get 269.633416, as you can see in the calculator there. And when I multiply 10 to the negative 11th times 10 to the 24th times 10 to the 12th, you just add the exponents, you get 10 to the 25th. And I put together my m and my m squared, make m cubed, kg and kg make kg squared, s squared on top, and then I add a kg squared on the bottom and a s squared on the bottom. Now you can see what cancels out here. And what I'm going to do before I go any further, I'm going to rewrite 269.6333416 in scientific notation. If you can see, I'm moving my decimal place 2 spots. What that allows me to do is add 2 to the exponent of 25, so I get 10 to the 27th. The good thing is, remember when we take the cubed root, we are dividing 27 by 3. Now, the only thing I'm left with as far as my units are m cubed. Now, when I take 2.696333416 divided by 4 pi squared, I get 0.068298421 times 10 to the 27th times m cubed. Okay, all I did was, you can see it in my calculator here, 2.6933416 divided by 4 pi squared, and I plugged it in there. Now, the cubed root of this decimal right here is equal to 0.4088 times 10 to the 9th. Now, the way how I get times 10 to the 9th is I took 27 divided by 3, and then how I got just m, I took 3 divided by 3, which is 1. Now, to finish this problem up, you have to move your decimal place 1 spot right there. And what this does is it subtracts 1 from the exponent, so you get 4.088 times 10 to the 8th meters. Just press replay if you want to follow how we did that again.